Okay, video two. Hopefully the first video worked. I don't know. A little nervous on that, but we'll see. We'll see what happens. So this is video two. I think I left you kind of hanging there on that. So let's just go over this. Two pets are selected at random from a group consisting of 4 dogs and 2 cats. Find the probability that both pets are cats given that at least one is a cat. So what we're going to do here is given, looks like this, probability of A given B, probability of A and B over the probability of B. So to do that, what we can just do is instead of using the probabilities, we can also use, we had this earlier where we said instead of doing that, we could say N A and B is over N B. So instead of doing the probability, because the denominators will be the same always, we can just count. So 2 pets are selected around from a group of 4 dogs and 2 cats. So 4 dogs and 2 cats. So we're saying at least one is a cat. What's the probability that both are cats? It's a fair question. So the probability of both pets are a cat, that's your A, and the probability, and B will be at least one is a cat. So that's what you do given. So when you have a given question, remember that you have the first thing is your A and your second one is your B. So what we do here is the probability of A and B. So that's the probability of two cats given, or sorry, 2 cats and one is a cat. That's a weird question here, right? But what you're saying here is 2 are cats and one is a cat. So really what you're saying is how many ways can we have 2 cats chosen? And the way that happens is just C 2 2, okay, or 2C2. And if you want to choose 2 cats and of them, sorry, 2 pets, sorry. And for B, at least one pet is a cat. We have to look at 2 cases, one where they're both cats and one where one's a cat and one's a dog. So you're choosing 2 cats of both cats, right? So you have 2 choose 2. And what you could also do is say 2 choose 2 times 4 choose none. And then you add to that here where 1 is a cat, so 2 choose 1 times 4 choose 1, and that's where 1's a dog. Okay, so there's that and that. So that one there, a little bit different, but check your notes on that. We have a bunch of good questions like that. You play a game, you win a game, continue rolling until you get a 2 or 6 with the probability that you will win the game. So I'm not a huge fan of the wording of this question here. And that's why Mr. School here has written this question like this. What is the probability that you win the game, given that you continue to roll until you get a 2 or a 6? And I've got to be honest with you, I don't even like how this is worded in the reword. So let's just skip over that, okay? Make our lives a lot better than just spending 20 minutes trying to figure out what the question is asking. Not that we couldn't, we definitely could, but not during test time. Okay, so now you have a different situation. You have a situation, the results that 30% entering first year fail by that's sad, but 30% fail. If a student survives the first year, survives, that's impressive. Oh, that was a mistake. He or she has an 82% chance of graduating. That's great news. Find the probability that the student entering first year will graduate. So what you're doing here is you're just drawing a little tree, and you have your first year and then graduate. Now, don't forget here, if you fail, you're not going to graduate, so you don't need to go through this and say fail and then graduate. It doesn't make any sense, okay? So what you're doing is drawing a tree like this. 70% pass, 30% fail. Where does this come from? Well, 1 subtract 30 gets you the 70. And then at this point, you have this. You can put an 18 here, but it's not going to mean anything. And then you just multiply them out to figure out the end product. Remember, when you have things like this, you're going to multiply branches. Okay, so if you have values on different branches, whatever they are, even if they're fractions, let's say you have a half and a half like this. Okay, you will multiply to find out what the probability of the end is. Okay, and I'm really nervous because I tried to upload the video earlier and it didn't look right, so I might have to go back and make the first video again. I don't know. A Canadian city has a morning and an evening newspaper, so you can tell this is a very new question. 35% of the city's population read the morning paper. So you have the morning paper people, there's 35, so here's your morning. And then here's your evening, 48%, 15 do both. So you want to put that 15, there's a 15 in there. I think I'll just mess it up worse. So in the intersection there, you'll notice that there's 15, which makes this 20 because all of the morning adds up to 35. So the 15 subtract that would be that. Be 20, sorry, and then that gets you 33 over here. And then just answer the question: the person who reads the morning paper, what is the probability that the person also reads the evening paper? So this was a little different. So the wording of this, you might not realize that this is a given question, but it really is. And it's saying that what is the probability that the person also reads the evening paper? If a person reads the morning paper, what is the probability that the person also reads the paper? That can be reworded as what's the probability that the person reads the evening paper given that they read the morning paper? Okay, so the wording of that is a little tricky, but that's saying if they have already done this, so that's the second part. So that's your B of your A and B, and then you just go through this and say P A and B is 15, P of B is 35 that were given initially, and then you figure that out. Okay, so the wording of that a little bit tricky, but not too bad. Well, actually, that is pretty bad. Anyway, you're tossing coins. This question here is you toss a coin for chance, probably that each you toss the same number of heads. So what is happening here is you need to figure out the probability of all these things happening. So this is you, right? And what happens is in case one, you both flip 3 heads. This is a tough question too. Maybe not really a test question. I would say it may be a bit too much. And if I was studying for a test, I would probably ignore what I'm about to say. But you would look here and say, this is 1 head. So there's a 1/8 chance that I get 1 head here because, sorry, this is 3 heads. I'm sorry, 3 heads. So 3 heads happens 1 out of 8 times. Okay. So if that happens, so that's case 1, you have 3 heads. Case 2, you have 2 heads. Case 1, you have 1 head. In case 3, you have 0 heads. So that happens 1 out of 8. And if I get a 1 out of 8, my buddy has to get a 1 out of 8. Okay, so that happens a total of 1 out of 64. So you're going to multiply these two. And then you multiply these two and whatever. And test, I don't know if I would bother with this. Some of these questions are getting a little bit weird now. So they're not necessarily test questions. So I would not look at that one if I were you. But it's there. The answer's there if you want it, but don't bother. Sorry, I'm just trying to move this. Again, also here, you got a lot of stuff going on. It's quite a bit, so skip it. Was probably throwing 2 5s in a row. So 2 5s in a row. So with a pair of dice, the wording of this is a bit confusing, but you have your 6x6. So what happens is there's a 4 and 6, 36 chance of getting a 5, and then there's another. So what I would do is draw a tree here, and then you have a 5, not a 5, and you have a 4 out of 36 chance of getting a 5. Okay, because there's 4 ways to get a 5, and there's 36 total. And then here it's a 5 or not a 5. 5 and not a 5. Sorry for all that. And this would also be 4 out of 36. And what you're just going to do is figure out this branch here is 5 and 5. And what you do is 436 times 436, which is 16 over 1296. So I would draw a tree for that, but you don't need to. You just do it that way. And that's it for that one. And we're almost done. Unless I have to go make the other video, then you're almost done, and you won't even realize that I went back and made the other one. This question, what you're doing is choosing, you're going through this and you're what I would do is write this out like this. So what you have is the white balls, and then you have after there you have, so you have 1, 2, 3, 4, sorry, then you have the red balls, then you have the blue ones, and then they have numbers on them, and then you're trying to figure out, find the probability that the balls will be of different color, each marked with an odd number. So that's a really weird question here. But what you're doing is, how often can that happen? So you want different colored balls that are of odd numbers. So this is a fair question. It's a difficult one. So if you don't like the wording of this whole thing, I would skip it again. But if you want to keep going with this, what you're saying is that there are two odd W's, 1 odd red, 2 odd blue, and what is the chance of getting those balls if you pick 3 of them out? And my answer would be this: 2C1, because you have to choose one of those times. 1C1. That's choosing one of the 2 red white balls of these 2 odd white balls This is choosing the one odd red ball, which is only one red ball in total, and 2 choose 1 is choosing the one of these 2 blue ones, and then that would be over what you're doing. So that's like this. So what you're doing is there are 3 balls you're choosing. There are 10 in total, and you're choosing 3 of them. So that's your denominator. Okay, so the wording of that's a little confusing, but I think it makes sense if you look at this. Okay, so you're choosing the 2 of these 2, 1 of this, and 2 of these. That's your numerator. Again, success on the top, and then total on the bottom. This question is horrible. Don't bother. Okay, that's fine. And same with the continuation in C there. I would stop with that. Okay, so I don't even look at that one. I said don't look at it. Okay, stop looking at it. Okay, and that's it. Hopefully the first video worked. If not, I gotta make it again. Hopefully this one works.